Okay, next lesson. We are moving on to lesson 7, and we're looking at solving systems of linear and quadratic equations. Um, like a lot of things, on paper it looks scary, but in practice it's really not. We're not really going to be doing anything new this lesson. It's just kind of how we're applying everything. The skills that you need to do this, you should have pretty well in your toolbox now, all right? So, what I want to do is I want to try and relate this back to something you do understand and something that you've done, which is solving systems of linear equations, all right? And if you remember that, okay, the system of equations is two equations where the solution is when you're able to graph them and they meet in the coordinate plane, or you're able to figure it out algebraically. And I have an example here, and you can see that the solution to these two equations, so this negative 1 half x plus 3, this top one is this blue line, and then green is this 1/4 x plus 1.5, and I can tell that because that's got a positive slope. This one's going up, this one has a negative slope, it's going down. And where they meet, so the point, it looks like about the point 2, that point where they meet is the solution to the system, right? And if you remember, there were three different scenarios you had with linear equations, and that was where you had one distinct solution, right? So something like this. You had no solution, so that happened when they were parallel. And then you had all solutions. In other words, anything on the line was a solution. So infinite number of solutions. And that was when the lines basically line on top of each other. So what we're going to do is we're going to look at the same kind of situation, but we're going to apply that to quadratics, all right? So how is this the same, different when your system includes a quadratic and a linear equation together? Well, we know it's going to be the same, that in the sense that where they meet is going to be obviously solutions, but the thing is, it's, we're going to have some different things going on. So think about a quadratic equation and think about how when we were finding zeros for it, right? When we were trying to figure out what do you get when you make y equal to 0 and you find your solutions to it, there were always the three different cases, right? We had the two solutions, we had the one solution, and then we had no solutions, right? So I have a feeling that if you followed along with that, this is probably going to be a lot like that. So let's go to Desmos. I love Desmos. And we are going to put in a few different situations and see what we get. So we're going to start with this one where we have y equals 1, all right? And that's this line right here. I'm going to make this bigger and then zoom in so you guys can see this. All right, we'll zoom out a little bit. It doesn't have to be quite that crazy. All right, bring it down a little bit. And then we are going to put in a quadratic. So y equals, now I'm going to put in x squared plus 1. All right, so if you look at this one right here, y equals 1 and y equals x squared plus 1, we have a situation where this basically is just coming down and it's touching the other point right at this point, at the point 1 0 or 0 1, sorry. So that is the point that if I put that into this equation and into this equation, it will make them both true. Remember, algebraically, that's how you can tell if a solution is correct. It makes both of the equations balance out, right? So this is a situation where you have one solution. Now, like solving for quadratics, you could see where maybe that's not going to be the case most of the time. Because with quadratics, most of the time you have two solutions, right? And this is probably very similar. So let's look at another case. All right, so let's get rid of this and let's put in y equals, we're going to do 3x minus 4. So we have a line with a slope of 3 that with a y-intercept of negative 4, right? So it goes up 3 over 1, up 3 over 1, right? We're getting that, right? And then our next equation is a quadratic. Y equals 3x squared minus 12x, oh, what happened there? Minus 12x plus 10. All right, and that plus 10 raised it up, right? So 10 is the y-intercept. You can find your axis of symmetry, right, by doing the negative b over 2a. So you have negative 12, so that would be 12 over 2 times 3, which is 6. All right, so y equals 2, and if you look at this, that's where your vertex is, and that's where your line of symmetry is. All right, your zeros are right here, which are kind of ugly numbers. And then you've got your solutions right where they meet. So this is a case where you have just two solutions. And no matter what you do, you can pull out of this, right? We can zoom out and you can see that that quadratic just continues to go up and up and up and up and up and up, right? No matter what. But they only meet in those two spots. All right? So this is a very common occurrence with the systems of equations where they're going to have 2 points where they meet. So you have two solutions. And that's fitting if you think about how quadratics are. All right, so let's look at the last situation, and hopefully your brain is going and you're thinking, oh, well, what about if they don't touch? Well, what about if they don't touch? Let's look at what happens there. What does that look like? So I wrote this one in vertex form so you guys could see kind of what that looks like. So, and let's talk about our transformations real quick. So if you take your parent function, right? If you take y, let's throw a third one in here. If you have y equals x squared, right, which is the blue one, and then you take it and you make it negative, right? So you take this, that flips it, and then you change its vertex from 0, 0 to the point -1, which I got from here, and then 2, and that moves it right up there, and that's how you get that red curve there. And so if you look at this, right, no matter how you look at this, these never meet, right? They don't, because you can say, oh, well, maybe they meet here, but that's only because we're zooming out. And so effectively it looks like when you go out this far that they're touching, but they're not, right? They're missing each other by probably about 2 units or so. So these never touch each other, and because they never touch each other, they don't have any shared points. That is the solution to both equations. So in that case, we would say no solution. So it's very similar to how you think about what the zeros are for a function when you're solving a quadratic, either by using the quadratic formula or factoring, completing the square, whatever it is. Those are when it crosses the x-axis. The only thing that's different about this is instead of focusing on when it's crossing an x-axis, we're focusing on when or if it crosses this other line that's being introduced to it. So that's how these work. You have your 3 different solution sets, which you should be familiar with now. And in the next videos, we're just going to look at some examples of these.